Let's start with what we call prime factorization. So that's breaking down a number into all products of prime numbers. So all prime numbers multiplied by themselves to give you 45. And we most often do that with those factor trees. Remember those in grade school? Okay, so if we were going to write the prime factorization of 45, okay, to two numbers and multiply to give you 45, 9 and 5, we can do that. Okay. We know 5 is prime because it has no more numbers that divide it besides 1 and 5. But 9 is composite. 9 can be broken down into 3 and 3. Good. So the prime factorization of 45 is 3 times 3 times 5. Right? Again, the order doesn't matter. Right? You could do 5 times 3 times 3. 3 times 5 times 3. Order doesn't matter because multiplication, it doesn't matter. Okay? This is what we call the prime factorization of a number. Okay? We've done these in grade school. We've seen these before. Okay? Then we move on to GCF. What does GCF stand for? Yeah. Very good. Greatest common factor. Okay. So we're talking about greatest common factor. Okay. What is a factor? When we say the word factor, what does that mean? Yeah, it goes into another. It divides another number. Divides it evenly where you get an integer out. Okay. So for example, what are just the factors of 18? 3, 6, 2, what else? 1, 18, we're missing 1, 9, yeah. So those are all the factors of 18, okay? We know what factors are. Okay? When we talk about greatest common factor, we're comparing two numbers to start with, and we'll start comparing more things. We're comparing two numbers, we're finding out which is the greatest factor. So the biggest factor of 18 is 18, right? The second biggest is 9, and so on. So if I said find the GCF between 25 and 15, you would say it's what? It's 5, right? Excuse me. Pretty straightforward. 5 divides both, excuse me, 25 and 15. There's nothing greater that divides both of these numbers. They don't have a greater factor than 5. Okay? So that's what GCF is. We're going to be dealing with GCF a lot. Okay? And finding the greatest common factor. But of course, we're going to take it a step further than what you did in grade school. Okay? Instead of just dealing with numbers and just dealing with GCFs of numbers, we're going to deal with monomials, binomials, trinomials, and so forth. Okay? So, let's factor. This would be a good place to start your notes if you haven't. I want to factor 12x squared y to the third. This is a monomial, right? Just out of curiosity, what's the degree of this monomial? 5, right? It's a 5th degree monomial. You just add the exponents of the variables. Good. Okay. So to factor it means to break it down into all prime numbers, or where we can't break it down any further. We know how to prime factorization 12. We know how to get the prime factorization here. We know how to break down 12. If we do the factor tree, which is a fine way to do it, you could start with 6 and 2. You could start with 4 and 3, right? 3's prime, can't break down any further. 4 breaks down into 2 and 2, right? So 12 breaks down into 2 times 3. Again, the order doesn't matter if you did it a different way. Okay? So I have factored 12. I've broken it all the way down. Now let's look at this x. This x is how many x's being multiplied? 2, right? So it could break down into x times x, because it's 2 x's being multiplied. So I can tack that on here. That's times x times x. Okay. And the y is how many y's being multiplied? 3, right? To the third means 3y. So that's times y times y times y. Can any of these things be broken down anymore into more factors? No. They can't. So that is the prime factorization of 12x squared y to the third. Again, if you had 3 times 2 times 2 here, that's also correct. If you had 2 times 3 times 2, that's also correct. Okay. The order doesn't matter, but I've broken that down into all prime numbers or things that cannot be broken down any further. Yes?
Do you have to break it down?
Good question. You would not want to do 4 times 3 times x because 4 can be broken down further. Okay. And the way we get these numbers is just the end of our tree. Remember, if you like doing the tree, that's 2 times 3 times 2. Okay. So we have factored that. Let's look at one more factor here. Let's say factor 38 RS squared T. I'll let you try that one first. I want you to factor 38 RS squared T. All right, so our only option for 38 breaks down into what two factors?
2 and 19.
Good, 2 and 19. Okay? That's the only way 38 breaks down anymore. It's not divisible by anything else. 2 is prime, 19 is prime, can't go any further. Okay? So I know it's going to be 19 times 2 or 2 times 19, doesn't matter. Okay? Can I break down R any further? No, it's just R, right? It doesn't break down into anything else. So times R. But S squared is 2 S's being multiplied. So that's times S times S. T can't break down any further. So that's times T. So that is the prime factorization of 38R squared T. We're going to find the greatest common factor between, let's say, 12x squared and 16x. So what's the largest number and amount of variables that can divide both of these things? Let's first just start with the numbers 12 and 16. If you were just looking at the greatest common factor between 12 and 16, what would that be? 4, right? 4 is the highest number that divides both of those. Okay? So 4 divides both 12 and 16. With the variables, we're going to see how many variables do they have in common. They each have one x, right? This one happens to have 2 x's, but they each have at least one, right? So they both have one x in common. So the greatest common factor between these two things would be 4x. Because you could divide them both. You don't have to show this work here. But you could take 4x squared divided by 4x. Remember, 12 divided by 4 would be 3. X squared divided by x. Remember, when you're dividing the exponents, when you're dividing the same base, you subtract the exponents. 2x's over 1x is going to be 3x. So that divides evenly. And if you had 16x divided by 4x, 16 divided by 4 is 4. X divided by x is 1. That's 4. So it divides both of those things. Right? Another way you could have done it is you could go ahead and write the prime factorization of both of these. Let's say this is 6 and 2. This is 3 and 2. This is x and x. You don't have to do this either necessarily. This is 8 and 2, 4 and 2, 2 and 2, and that's just 1x. Okay? And I look, what do they have in common? They each have 1 2 in common. Well, they each have another 2 in common, and they each have 1x in common. Right? So what they have in common is 2 times x, which happens to be 4x. Okay? That's what we're looking for, what's in common, their greatest common factor. Here they have 2 2's, which happens to be 4, 1x, so that's how I get the 4x. But you don't have to write this out every time if you can recognize it without doing it. Okay? All right, let's try a little bit more difficult one here.
Wait, we have to break down the greatest common factor like you did there?
You can, you don't have to.
No, I mean like the 4x. We have to break that down.
The 4x? No. The greatest common factor, you don't have to write the prime factorization of it. Good question. Okay. That just is the greatest common factor. Okay. So let's try this. Find the GCF of 9x squared y to the third and 27xy squared. I want to know what is the greatest common factor between these two monomials. You can just start with the number first and then look at the variables. Looking at just the coefficients first, 9 and 27, what's the greatest common factor between 9 and 27? 9, right? 3 is also a factor of both of them. But the greatest common factor is 9 because both of those numbers are divisible by 9. let's look at my variable x. I have two x's being multiplied here. I have one x being multiplied here. So how many do they have in common? They each have one x in common. And I have three y's being multiplied here. I have two y's being multiplied here. So how many do they have in common? Two. They each have two. This one happens to have three, but they share two at least. So they both have two in common. This would be my greatest common factor. Again, 3 is a factor. Y to the first power is a factor. But 9 is the greatest. Y squared is the greatest. That's the most y's they have in common. Okay. All right, so last GCF problem we're going to talk about today. I want you to find the GCF between these three monomials.
0.
Monomial here, monomial here, monomial here. What's the greatest common factor for all three?
Is this like a trick question when it's actually 0?
Three.
Not necessarily. Look at your variables too.
3 and 3x.
So let's look at these individually first. Let's look at the coefficients. 12, 15, and 18. What's the greatest common factor between 12, 15, and 18? 3. All those numbers are divisible by 3. So again, if I needed to, I could break these down and look at their prime factorizations. And just circle what's in common. They all have 1, 3. There's nothing else they have in common, though. That's the greatest common factor. Okay. Let's look at the x's next. There's two x's here being multiplied. There's one x here being multiplied. There's one x here being multiplied. What's the most that they share? 1x. Right, good. Right. 3x. I have one y here. I have two y's here. I have one y here. What's the most y's that they share?
1.
They each have one y, right? I have one z here. I have no z's here. I have one z here. They don't all have a z factor, right? They don't all have a factor of z. So I can't include that in my greatest common factor, which means 3xy is my greatest common factor. This common factor, we're always looking for the most that they have in common, the most variables and the highest coefficient.
18x